Hello, my name is Arghavan Sanei and today I present our paper, The Impacts of Sentiments and Tone in Community-Generated Issue Discussion. This research has been done in HCD Lab at Polytechnique Montreal. My co-authors are Jinghui Cheng at Polytechnique Montreal and Bram Adams at Queen's University. The maintenance and evolution of most open-source software projects rely on the issues generated by the members of the community. Modern software engineering tools such as issue tracking systems enable managing these issues on a large scale. The diverse community members who contribute to the discussions on issue tracking systems of open-source software projects often exhibit complex affective states with various sentiments and tones. They represent two major perspectives about human affective states: a dimensional perspective which can be captured in sentiments, and a categorical perspective which can be captured in tones. In this project, our objective is to understand the impacts of sentiments and tones of open source software community members when discussing and addressing the issues. Specifically, we ask 4 research questions regarding the characteristics of sentiments and tone in issue discussions, as well as their impacts on issue discussion features and issue resolution time. In order to answer these questions, we collected data from 3 popular open-source machine learning libraries on GitHub: TensorFlow, Scikit-learn, and PyTorch. For data collection, we use GitHub REST API. Also, for data analysis, we use Sentiversity and IBM Watson Tone Analyzer to detect the sentiments and tones in a natural language text, respectively. We performed several investigations in order to achieve a satisfactory level of reliability and ensure the performance of the analysis tools we use. These investigations rely on a gold standard dataset that we created through manual analysis on the sample of issues and comments in the 3 projects. Particularly, 2 software engineering students manually classify the sample on the sentiment and tone categories, then discussed and reached an agreement. The results of these investigations indicated that the tool's performance was better at the sentence level. Please refer to the paper for the detailed description of these investigations. Then we used the configuration that indicated the best tool performance to classify our data again, and resulted in the final dataset, which included almost 33,000 issues and 200,000 comments from the 3 open source projects, all labeled with the sentiments and tones. Finally, we performed a statistical analysis to examine the impacts of the identified sentiments and tones in issue discussion on various discussion and development-related measures of these issues. In this analysis, we also examined how to issue length, commit size, issue reporter role, and issue type can influence these impacts. Again, the detailed approach can be found in the paper. The descriptive results demonstrate that the neutral and no tone are the dominant affective states, followed by the positive sentiment as well as the sad and frustrated tones. We have found various types of associational impacts of the affective states of issues and comments. Those are reported in the paper in details. Here, we only able to present some high-level results. As one example, we found that the issue with a negative sentiment or sad or a polite tone were associated with quicker posted comments. Besides, the posted issues with the negative sentiment or a sad tone had more extended issue discussions. Further, we found some interesting results about the relationships of affective states and issue resolution time. We found that positive comments sentiment were associated with the shorter resolution time, particularly in issues that needed only small commits. Also, sad issue posts or comments were associated with shorter resolution time for issues, particularly in issues with the medium or large sized commit. Overall, our findings painted a complex and comprehensive picture of the impacts of sentiments and tones expressed by the diverse open source software community members. We identify crucial roles of several sentiments polarity and tone categories, such as negative, sad, and polite. While we use existing tools in identifying the sentiments and tones, we made considerable efforts to investigate and optimize configuration for these tools and validated the automated results. These efforts can inform future studies using existing tools and pre-trained models for effective analysis. Thank you for your time, and I'm happy to take any questions.